Hello, I would like to welcome all of you watching this video. My name is Ioannis Tomkos and I'm a professor of the ECE department at the University of Patras in Greece. Our university is involved in several research and innovation projects related with 5G and 6G networks and their applications across various vertical sectors. One of those projects is the 5G-INDUCE project that focuses on open cooperative 5G experimentation platforms for the industrial sector network applications. Its main goal is to provide an end-to-end orchestration platform over enabling experimentation infrastructures for advanced 5G network applications that are utilized by the Industry 4.0 sector. I have with me Professor Franco Davoli of CNIT from Italy, who is the project coordinator, and Dr. Dimitrios Klonidis of UBTech from Greece, who is the technical manager of 5G-INDUCE project. They will provide to us more information about the project, its goals, and key objectives. So, let me start with you, Franco. Could you please provide to us a brief introduction to the 5G-INDUCE project?
Yes, with pleasure. 5G-INDUCE is a project that started on the 1st of January 2021. It will last until December 31st, 2023. And it has been funded within the H2020 program in the ICT 41 call. It is part of the 5G PPP group of projects, the 5G public-private partnership, and the call specifically was of 5G innovations for verticals with the third-party services. The total effort that is foreseen for the project is over 1,000 person months. The project includes 21 partners from 8 different nations, and it has a total budget of 6 million euros from the community, 8 million euros total cost. As Professor Tomkos already mentioned, the main goal is that to provide an end-to-end orchestration platform based on a clear concept of separation of concerns between the network application world and the networking world in order to provide the network applications with the 5G capabilities. So to enable the experimentation infrastructures for the experimentation of advanced 5G network applications in the Industry 4.0 sector. And to validate the other main goal is to validate the readiness, the 5G readiness of telecom operators and application providers by experimentation over a complete system platform that enables the smooth porting of NetApps in the Industry 4.0 ecosystem on top of 5G networks.
Excellent. Thank you very much, Franco. I guess now we can go to Dimitrios, who, as technical manager of the project, could inform us about the main development goals, therefore the key innovations of the 5G-INDUCE project. Dimitrios.
Yes, thank you, Ioannis. 5G-INDUCE is mainly built around 3 development areas in order to achieve also all of its objectives. The main one, as also is the key objective of 5G-INDUCE, is first of all to have the capability to provide such kind of deployment and orchestration services for the NetApps, and this happens through the 5G-INDUCE orchestration platform. So the orchestration platform provides all the means required for providers, for end users, to develop, deploy the network applications, do the onboarding, and during operation have also the capability to do the lifecycle management of those applications over southbound 5G infrastructures. And we pay particular attention there over two directions. Let's say the southbound part of this orchestration platform that essentially do the allocation of the resources in an intelligent manner, but also has the capability to interface with different types of infrastructures, 5G infrastructures, either programmable, non-programmable, or with offering different features. The other part of this platform is the northbound interface to the end users, where we want to have also an environment there, and a quite nice and explainable environment for developers to be able to define, first of all, the functions, the application functions, the network functions that compose such kind of applications, and then compose, of course, also the application and provide some key characteristics. So that is one key development area. It's the enabler, let's say, of everything. The second big development area is the things that, the applications that we have, let's say, to play with, okay, those things that we have to deploy, and that is the part of the use case NetApps. Okay, so there are specifically 8 use cases, and all of them have the focus on some key industrial applications, quite diverse, okay, with different characteristics, but having also something in common. We want the functions or the different software components that are developed to be actually reusable, and we have certain use cases where certain components can be reused in other parts or build completely new ones, being able also to attract any kind of third parties, providing some additional components or changing the network applications that have already been defined. So there is a lot of effort for the actual development of such kind of components, but also in the way that these are put together, are linked together in order to form the network applications. The third, of course, development area is the where all of these are going to be deployed, how we're going to showcase it, how all of this will be nicely shown. And this is the so-called experimentation infrastructures. And on that direction, we have some very specific areas, okay, called them experimentation infrastructures, built in Spain, Italy, and Greece, with and followed up also with the so-called DevOps test. But as we know, it's like a platform where we do all the initial testing of the NetApps, and it is quite helpful also in order to improve the platform, improve some certain functionalities, test use cases as well, and the way that this can be deployed. So all of them form, let's say, the technical part. And of course, there is, I should mention also a fourth direction. This fourth direction goes towards also the enabling businesses, the business models, okay, how such kind of NetApps can be of benefit to NetApp developers, to network operators, and of course the end users, which are the industries in this case.
Thank you very much, Dimitrios, for providing us information about the main development goals of the project. Of course, all those developments will be utilized to demonstrate advanced 5G use cases for these NetApps over the available experimentation facilities. So I would like to ask Franco to provide a bit more information on those experimentation facilities. And then we can discuss more in detail the use cases to be demonstrated over those.
Yes, experimentation facilities will be provided, are under development, under advanced development now, because we are in the second year, almost at the end of the second year of the project, in Italy, in Greece, and in Spain. And they include all that is necessary to support the application, the experimentation of the application environments of the use cases. In particular, they have the capability to run over a 5G environment the applications by running the main software components that make up the platform, in particular the network application orchestrator and the OSS, the operation support system, that interact among them in order to allow the applications to convey their networking needs to the network operator and to provide to the applications that run in a complete cloud-native environment, provide them with the capabilities offered by the 5G networking. And in particular, so the experimentation facilities sit on top of a completely ETSI compatible NFV orchestrator that on the basis of the information received by the network application orchestrator through the operation support system conveys the setup allows the setup of the networking slices that are needed to conduct the experimentation.
Excellent. That's very clear. Of course, these experimentation facilities will be used to demonstrate the novel use cases enabled by 5G. So perhaps, Dimitrios, you can give us a bit more information on which exactly use cases are to be demonstrated and what can be possible benefits for the Industry 4.0 sector utilizing those.
Okay, 5G-INDUCE have 8 specific use cases. As it was mentioned before, those use cases primarily target the needs of the industry, of the Ford industry in Spain, okay, of Whirlpool and of PPC, and they somehow are tailored also to the needs, okay, of a factory which of course is responsible to manufacture cars, okay, so big machinery as well, okay, to Whirlpool, which is also it has some certain production lines, okay, of different household equipment, but also to PPC. PPC is it's an industrial site, okay, responsible for energy, for power management and power production over the electricity grid. Use case 1, use case 2, and use case 3 are pretty much involved with AGVs, okay, more specifically with automated guided vehicles. Okay, so use case 1, for example, has to do with the management of a small fleet of autonomous guided vehicles, okay, AGVs, as I mentioned before, with some localization, mapping, navigation systems. And the interesting thing there is how this can be managed seamlessly through outdoor and indoor environments. Use case 2 takes also the operation of AGVs to another level where we want to add some features very handy to the workers, like with gestures, okay, to identify gestures from workers, okay, some special signs, for example, which can make those AGVs move within the environment. And a third use case extends the main principle of remote operation with using, for example, 360 degrees video on top of such AGVs, quite challenging actually because of the delays that such bandwidth-hungry application requires, and also the capability to steer it remotely. And those are developed as individual, for example, use cases, but then we want to see also the combination of them, of different functions, in order to create separate network applications, okay, NetApps as we call them, okay, in different environments. Use case 4 goes to another, let's say, dimension, because this one is based on machine learning supported edge analytics and predictive maintenance. So its goal is basically to in an intelligent way to collect and process a number of different analytics and a number of different data that can be shared within an industrial environment, and then have some quite dedicated decisions, okay, that has to do, for example, with the maintenance within the industry, of course, with the goal to save cost. The interesting thing, for example, about this use case is to see also how this can be adapted within different environments, like, for example, in Whirlpool and then in PPC. Okay, so it's a pure manufacturer and then an energy providing company. Use case 5 enters the whole, let's say, world of inspection, surveillance using drones. Okay, it's quite interesting as well, and impressive. Okay, because there is the need on one hand side within a NetApp to have the management, the control of the drones, of the information that, of course, is carried. Okay, but also have some advanced video processing and analytics engines being installed in the network in order to see the outcomes of this one within a certain environment. Okay, in the same concept, use case, another use case 6, has to do with augmented reality-based maintenance, repairing, upgrade, I would say also guidance in general to the workers within certain environments. Another very nice example of an application that has a certain basis, but then different components can be used, okay, in order also to address, for example, different type of end user devices. It can be glasses, it can be, for example, some tablets, okay, or a phone, but also different environment, even more important, okay, something that, again, can be seen, for example, over the Whirlpool and the PPC environment. There is a quite interesting, okay, which use case 7, which basically was derived directly from the needs of the industry, okay, of Whirlpool, and in this case, and its purpose, it's basically to reduce accidents, to have through some real-time tracking of the position of forklifts and humans within a certain area, avoiding collisions, meaning avoiding accidents, okay, and have a much smoother also, okay, operation. So it's an indoor fleet management essentially approach. Finally, something which is again an application that is very useful for this kind of industrial environments, and apparently is required a lot, especially when the industrial environments have quite large area of operation and indoor outdoor environments and so on, is to assess the network performance, to assess the coverage, so that we know that all the applications can actually smoothly run within certain requirements and targets. And this is basically what is offered through use case 8, which can also use drones in order to have a quick coverage and analysis of certain areas. Again, an application that we want to see this being adaptable, okay, under different conditions, different networks, and different industrial environments. So as you can see, these are 8 use cases, okay, but through these use cases, there are even more scenarios that are generated, and also combination of the different functions that are built in order to have also further improvements. And this is what is also open to third-party experimenters, to other, developers, even outside of the consortium, and, to come examine them and even, provide some modifications to certain components, or even build within these infrastructures any kind of new network applications.
Very good. I would like to thank very much Franco and Dimitrios for the information they provided about the project to all of us. I hope that their responses to my questions offer to all of you some useful information about the 5G-INDUCE project, more information about the experimental facilities, and also the platform that 5G-INDUCE has developed to implement this 5G network applications and deploy them over real 5G networks will be discussed by the related expert partners later on. So thank you very much for your attention, and I hope that we will receive your feedback.